number 7, we're trying to find the inverse of x squared plus 9, and you'll notice that we have this stipulation here that it's for x is greater than or equal to 0. Now this is not involved in the math, but it is needed to make my original function one-to-one. And kind of like we talked about before, if your original function is not one-to-one, if it does not pass the horizontal line test, then your inverse function will not pass the vertical line test. So this is not really going to be used in our math for finding the inverse, but it's still important to have here. Otherwise, our inverse would actually not be a function. So if I take this out of functional notation, and then I swap the x and the y. Wherever I see a y, I want to see an x, and wherever I see an x, I want to see a y. So then I need to solve for y. So if I subtract 9 from both sides, I get x minus 9 is equal to y squared. And then to get rid of the squared, I want to take the square root. And that's going to give me y is equal to square root of x minus 9. And I want to label this as f inverse is equal to square root of x minus 9. So that's our answer. Again, we never used this in the algebraic process for this, but again, what this is talking about is, because it's a parabola, if you reflect it, it's going to look like that, and this is not a function because it hits it in more than one location. So you would need to cut this off. That's what the x is greater than or equal to 0 is saying here. They're saying just look at the positive of that, so that when you reflect it, it's going to look like that. And this is a function because a vertical line does not intersect it in more than one location.